Next up, we have Giorgio Chatzimarkakis. I hope I've Chatzimarkakis. I'm sure you can do a better job at teaching me how to pronounce your name. Secretary General of Hydrogen Europe, which brings together industry players who support the delivery of hydrogen and fuel cell technologies. Are you there? Can you hear us?
I can hear you, and I hope you can hear me.
Yes, we can. First, listen to me in your name, and then following on to the more important topic.
It's a Greek name, Yorgo Chatzimarkakis. I grew up in Germany, so it's a German pronunciation of it. Thanks very much. Thank you very much for the invitation.
Thank you, Yorgo. Over to you.
Many thanks. It's a pleasure and an honor to speak to this panel here and to this audience. Basically, I just got you one slide, and if you wish, you can move to that slide. And that's even not a slide that we produced, Hydrogen Europe. That's a slide that the European Chemical Society produced. And it shows the 90 elements, the 90 natural elements that make up everything, but it shows them basically in the volumes that they are available. And also the colors show whether they are threatened or limited, threatened or really threatened. And what is important for us is that we as Hydrogen Europe and also trying to co-organize together with the European Commission, the so-called European Clean Hydrogen Alliance with more than 1,300 members so far and coming up with concrete projects. We are at the brink of basically a change from the Anthropocene that we think we are in. So the era where we humans impact basically our planet much more than we should, to the Cyclocene. So we have to become cyclical. We have to become mastering the processes that we know from nature. But in order to get there, we need a lot of platinum, and I will explain why. So hydrogen has been basically discovered as a science fiction thing quite early and quite in the beginning of this century. At least there was already a hydrogen hype, Jeremy Rifkin and his hydrogen economy. Yet we didn't have mature projects, and also the pressure to do the decarbonization was not big enough. So fossil fuels were cheap enough. And what we then saw when the pandemic broke out was very simple. Crises normally have an initial character to a major change. When the crisis broke out, the IEA took a snapshot of the energy demand in the world, and it had dropped dramatically in April last year, so exactly a year ago. There was one exception. So gas went down, coal went down, nuclear went down, just the renewables went up a little bit. And that was taken as a good moment by some policymakers to say, okay, this is a very good basis for a disruptive change and for something new in the European Green Deal. We presented this paper here, the 2x40 gigawatt initiative, basically the same time, by coincidence. And the Vice President of the European Commission, Franz Timmermans, literally picked it up and said, hey, guys, can we take this in order to make it one central pillar of the energy transition, which in the end is not only energy transition, it's also mobility and industry transition. We said yes, and we elaborated on that. Now this 2x40 gigawatt have become a target of the European Commission, of the European Hydrogen Strategy presented by the Commission July last year, and we are currently working on that. 2x40 is something 40 in Europe and the other 40 in the neighboring regions like Ukraine and moreover Northern Africa, the MENA region, Middle East, North Africa. Now this means that we will see an uptake, a massive uptake, especially in the next years, of the electrolyzer technology and the subsequent use also of hydrogen with fuel cells. fuel cell. I'm driving a fuel cell car on a daily basis. There are unfortunately only two car OEMs that are producing them, Toyota and Hyundai, but they work. The maturity of the technology is very high. So what we will see the next years is a real upscale of both electrolyzers and fuel cells in order to make this other leg of the energy transition a reality. The first leg, I would say, is electricity. So the electrons will dominate everything. Also, we depend on electrons, but we need to then, with the electrolyzers, turn the electrons into molecules, because molecules can be stored easier, they can be dispatched and disseminated easier, although you have an energy loss. But in a system, in an overall system where you have endlessness of energy supply by renewables, this energy efficiency is less important than the overall system efficiency. And this is where we come into a discussion with you, because we believe that there will be a certain time, a certain timeline, where this platinum that we need in the electrolyzers and in the fuel cells, which is limited, of course, will need some more supply. Just to see the forecasts of different big analysts, in the year 2050, it's expected that hydrogen will cover 28% of the global energy demand. Mobility industry as well, because hydrogen is also a feedstock, as you know, is a feedstock for some processes in chemical industry, in the chemical, the petrochemical, fertilizer industry, also steel industry. So 28% is quite a high number, and in order to get there, we need to have a safe supply by iridium and especially platinum. That is where we would like to work with you and to see how best we can harvest the asteroids where the platinum group is represented. So that's one of the major aspects I would like to highlight here with you. I can also say, you might argue, well, hydrogen is not that well developed. Why don't we go for battery? I think, and here I'm very clear, that there are some, some non-fact-based issues going around. Today, the European Commission publishes the taxonomy. Taxonomy means what is right and what is wrong for sustainable investment, what is sustainable, what not. There's also a threshold that has been published today with regards to clean hydrogen. But I would like to focus on the battery. The battery in this taxonomy has been put on a position of saint. Don't touch it. You don't need to do an analysis, a life cycle analysis. It's sustainable. And I think that this religious approach will disappear more and more because, as you see on this chart here, many elements that you need for the battery production, even if batteries will, of course, have changes, we'll see changes, will become much more efficient. Even then, this chart here shows that there is a clear bottleneck. Give you one example. We have discussed in the EU and issued a 300 gigawatt offshore initiative until 2050. That means that we need 13 times the power grid. And you can imagine how much of copper we might need to ramp the power grid that is already quite big, 13 times up. We need the same copper also in the wind generators, and we need to decide where to put it. So that's why we will have an issue. We will put them, of course, in the wind generators in the long run, and then how to transport the electrons without the grid. This is where hydrogen again comes in, because we have a very dense gas grid in Europe with more than 200,000 kilometers of gas pipelines that we can repurpose and then use for the transport, for the storage, and much cheaper storage of these molecules and of this renewable energy. Now, finishing, I would like to also highlight that once we have this harvesting activity of this rare earth, of this material, these elements that we need, especially platinum, how to get there, I don't need to explain. I think the ESA was, and the Ariane program was for many, many years the biggest single client of hydrogen in Europe. especially liquid hydrogen. And this is where we also see, of course, a potential to work closer together with you. So these two aspects are for us very important. Hydrogen as a fuel for the space activities, and second, platinum and the platinum group as the most important issue that we would like to look into with you. I would leave it there, and again, thanks for the invitation. Thank you.
Thank you so much, Jorgo, and absolutely love that slide. It's fantastic and so interesting and amazing that you can give a talk with one slide. Fabulous. Over to you for questions.
Yeah, ironically, exactly at the moment where we were talking about batteries, my batteries of my laptop died. So maybe for this time you can help me out and see if there are any questions.
Yes.
I think there was a comment about the charts.
There's all sorts of comments going on. So here we go. From Antoine, and Antoine is a systems and business engineer at iSpace Europe, possibly sitting here, I'm not quite, hello, Antoine. Yes, you are. Antoine, Jorgo, how do you see companies, organizations in the hydrogen value chain be involved in developing a hydrogen-oxygen economy on the moon?
Short answer, we have seen that on the moon, hydrogen might be the most interesting option as an energy vector, because hydrogen is much more than an energy carrier. It's like an electron. It can also store the energy, and that is why the temperatures on the moon are quite good for that, because liquid hydrogen is minus 252 degrees, and so it really can help to support all the activities by energy supply in a mainly liquid form, which is more dense and which then can help to do activities much longer. Oxygen is not the field where I'm a specialist in, but if you do electrolysis, water electrolysis with renewable electricity or any electricity, the result is of course hydrogen and oxygen. So oxygen is also always a byproduct. Thank you.
Jorgo, we can still hear you, is that correct?
Yeah, I can hear you.
Super, yes, great. Now, I've got another question here from Greg de Temmerman, who is the MD of Minds Paris Tech Xenon Research, and Greg has also been active on the chat the last few days. The question is, why not go to electrode-less systems for hydrogen production? Plasmolysis, for example, could get higher efficiencies and would work with microwave plasmas.
That's an excellent question, and I have to say that we are looking into that also as the hydrogen sector. I have to be very honest to you. This political bubble, this political decision-making systems needs to be taken by the hand step by step. So to be honest, without the pandemic, I'm super transparent here, it would not have been possible to catapult hydrogen into that sphere where it is now. So that was very important because there was the pressure Paris Agreement and climate deal, and now there was the pressure of creating jobs and most probably Green Deal jobs. So that helped us very much. And that helped especially the case of renewable hydrogen, renewably produced hydrogen. Now we are entering into the next phase. We need to, first of all, to let mature this approach. And I'm personally very interested into plasmolysis. And there we will indeed see the next step. The maturity is not that high so far. We see first projects that will also be have the character of being market oriented, but it's I would say 5 to 8 years behind electrolysis. Same applies to pyrolysis. Pyrolysis, splitting methane into hydrogen and carbon solid. Thank you.
There's quite a few comments going on about metal embrittlement, actually, and hydrogen embrittlement of steel pipelines. Have you got anything to talk to us about that? A few people are commenting on that.
So CO2 pipelines, say the word again, metal?
Well, it's metal embrittlement. Embrittlement.
Now, the pipeline system that we see at the moment, the 200,000 kilometers that I mentioned, are not all fit for hydrogen or CO2. We might also see ammonia pipelines. I'm not sure, because ammonia seems to be one of the derivatives, one of the power fuels that you can make out of hydrogen, which seems to be very, very interesting. And we call that repurposing. So many of the pipelines need a coating or a repurposing, and that's something that we are looking deeply into now. The cost of any repurposing are about 25% of a new build, and that's what the 10E regulation of the European Commission is about. 10E, Trans-European Networks for Energy, and we are looking exactly into the cost and also the feasibility of this repurposing in order to make CO2 pipelines happen. We will need them, because CO2 will be scarce in the course of time, and we will need CO2 also for the synthetic fuels that will be produced in the long run. Thank you.
Thank you. It's funny to hear that it might be scarce in the coming years. Thank you so much, Jorgo. You've engendered a lot of conversation online. Hopefully you can switch rooms as well to answer those questions on the chat directed to you. Thank you once more for a wonderful talk from a slightly different perspective from the previous talks.